we're going to look at kinetic and gravitational potential energy. Okay. So gravitational potential energy. So what we've got to remember is potential energy is the energy that's stored in objects and it's waiting to be used. So this energy can be stored in many forms. So we've seen it being stored in batteries, we've seen it being stored in all sorts of areas, but we're talking about gravitational potential energy in this particular little PowerPoint. So gravitational potential energy is the energy stored in an object that is high above the ground. So whether that's 1 centimetre above the ground or 1 kilometre above the ground, as soon as it's off the ground, it's got potential energy. The higher the object, the more gravitational potential energy it has. And it's also related to the mass. So the heavier it is, the more potential it is. So if you think about it, if you've got something that's heavier and higher, then it's going to have more potential energy. Okay? And we know this because if you think about it, when we lift a heavy object or a heavy weight or something, we need to put in more energy to lift it. Okay, so those weightlifters, and you think about them, the heavier it is and the higher they lift it, the harder it is. So they have to do lots of training to actually get the body strength to lift it up. And they eat a lot more food, so all of that energy going into the food for their muscles to lift things up. And as I said, we know it because to lift up something light is easy. To lift up something heavy and lift it to above our heads, we need a lot more energy to do that. So now we're going to look at kinetic energy. Okay. So the energy of movement is called kinetic energy. So anything that moves, whenever object or people move, they're using kinetic energy. So anything that's moving has got kinetic energy. The faster the object is moving, the greater the kinetic energy. So you move faster, the more kinetic energy you have. It's also related to the mass as well. So the heavier an object, the more kinetic energy it has. So if you think about something that's moving really fast and it's really heavy, is it going to be easier or harder to stop? So if you think about it, it's harder to stop an object that is heavier and going faster than a small object. We need to put in more energy to stop it. So, and this is just how kinetic energy works. So the heavier it is and the faster, it's got a lot more kinetic energy. So to either start it up or to stop it, we need a lot more energy to put into it. So let's have a look at this. A perfect combination of potential and kinetic energy is seen in a roller coaster. So I've just got this little clip off YouTube. Now it goes into a fair bit of explanation, but just listen and I'm sure you'll learn something along the way.
Are you ready? Going through, coming down, right through. Yeah. Basic underlying principles of a roller coaster start with one of the more fundamental laws of all of physics, and that is the law of conservation of energy. When we start to talk about the law of conservation of energy, what we're really dealing with is a situation that we know that in a closed system, the energy is conserved. What that means is that energy is transformed from one type to another, but the total amount of energy stays the same. Energy is defined as the ability to do work, and so what that begs is that a definition of work. And work is the idea of moving something by using a force on it through a distance. At the bottom of a roller coaster, the object has no potential energy. The train has no potential energy. So what we have to do is we have to supply energy to the system to bring it up and give it energy. So the machine is adding energy, supplying a force. That force is moving the object from a distance, and that's what we call work. On a roller coaster, what we deal with is two basic types of energy called potential energy and kinetic energy. Potential energy is the type of energy of position. And on a roller coaster, we're talking about gravitational potential energy, just the height that a roller coaster might attain. With kinetic energy, what we're dealing with is the energy of velocity or speed. And so as an object gains speed, it gains what we call kinetic energy. And then as we get to the bottom of the first hill, we're spot of energy that you'd like.
Okay, so what that means, if we've got a roller coaster that it's way up the top, it's up really high, it's got a certain amount of mass, so that means it's got gravitational potential energy. If it's stopped up there, it hasn't got any kinetic energy. As it goes down, it's going to get faster and faster and faster. As it gets down to here, then you have got some potential energy because it's off the ground, but most of that potential energy has been turned into kinetic energy. So it means that it's going really fast down here. Then it goes up to here and it starts to slow down. It's still not as high as here, so about here it's got probably about half of it is kinetic and half of that energy is potential because it's gone back up. So it slows down a bit and it'll go down, down, down and speed up until it gets to here. So it's got more kinetic energy here and less potential energy. Here it's got more potential energy, but it's also got plenty of kinetic energy, so it's probably about 50-50. Down here, it's got a lot of kinetic energy and less potential energy. This one, if you think about it, same. So it's got potential energy up here. If it's stopped, then it's got no kinetic energy, but if it's moving, it's got some kinetic energy. So it goes here, here, so it's going to gain kinetic energy, lose potential energy. Gets down to here, it's going fast. It's still got potential energy, but due to this height, comes up. It's going to slow down here, but it's still got enough kinetic energy to get through here, go down. So once again, it's up here, it's got a lot of potential energy, okay, less kinetic energy. Then it's going down here, it's going to increase its speed, so that means it's going to increase kinetic energy. Down here at the bottom point, it's going to have only a little bit of potential energy, and it's going to have a lot of kinetic energy. So this is where it's going to be going its fastest. It's going to come up here. It's going to slow down a bit, but if you think about it, it's going to be slower at this point because it's higher. So this is going to be going quite fast still around here, but it's going to go even faster here. So at the top of this point, because there's a lot more potential energy, it's actually going to be going a little bit slower than what it is here because this has got less potential energy. So that energy all has to equal the same amount as what it had at the very start. So I'm going to go on to a little bit of a challenge now. And what we've got is it's a challenge to design a roller coaster. So there'll be links to this in a little bit later. Now I've put this on fast forward. So this is me designing a roller coaster. So I've put it on fast forward. So the first part of it is designing your cars and how many cars. And you notice up here it's got your mass up the top, and so you can change your mass. Now I'm designing the what do you call it? The roller coaster. I've put in a little thing there, moving them around. So I've launched it. And so this will decide on how I'm going with my potential energy. So I've got enough to get round the loop, but I ended up with too much energy at the end. So I actually crashed through it. Now, what happens is it tells you, gives you ideas and everything. So basically you have to design a roller coaster where you've got rid of some energy so that it doesn't crash at the end and it gets all the way through. Okay, so it's quite challenging, but it's quite fun, and it's looking at how you combine your potential energy and kinetic energy. Okay, so what's that? Oh, hang on. So I forgot to put the thing on that one. Anyway, so remember, potential energy is stored energy. Gravitational potential energy is related to the height and mass of an object. The higher and heavier it is, the more gravitational potential energy it has. Kinetic energy is energy of a moving object. It's related to the speed and mass of an object. The faster and heavier it is, the more kinetic energy it has. Gravitational potential energy and kinetic energy easily transfer between each other. And make sure you note that some energy is lost. Remember, it's all conserved, but as heat, and that's because of friction and air resistance. And sometimes it goes into sound, so you can hear a roller coaster travelling along the tracks, so some of that energy is going out as sound. So it's not all perfect because of friction and air resistance and sound energy, but basically, in a mathematical sense, all the energy has to be conserved. It's just that we lose some as heat. Okay, thanks.